Okay, question 15. At what time does the ball reach its maximum height above the building? So, what we can use here is the fact that we know that the velocity is the derivative of the displacement, which means that the velocity is the slope of the tangent line to the displacement graph at any given x value. And what that means is that since the ball reaches a maximum height and then starts going down, that means at one point the slope to it, or the tangent to the displacement function, has a slope of 0, and that is when it has reached its maximum height. So what we need to do is, well, actually it just tells us the function for velocity. So what we really need to do is just use this function. V of t is equal to r, which is 5 meters per second, minus s, which is 10 meters per second squared, t, and figure out what value of t makes the velocity 0. What positive value of t makes the velocity 0. Well, there would be no negative value either, but so we just use algebra here. We have v of t equals 5 minus 10 times t. The velocity, we want it to equal 0, so 0 equals 5 minus 10 times t, which means 10t is equal to 5, which means t is equal to 5 divided by 10, which is equal to 1/2. So when the velocity is 0 is when we are at t equals 1/2 seconds. So that gives us the answer. The answer is C, 0.5 seconds. But what this really looks like, I'll draw a graph here. If we have our parabola here for the displacement of the object, we can see that the slope is becoming more and more negative as it reaches the top. This is because the acceleration is negative, which is which means the slope of the velocity is negative, so the velocity is becoming less and less, so it's very positive right now because the object is flying upwards, and this specifies that up is positive. So it's going up, and then the velocity becomes less and less until the velocity is 0 in the y direction. And that's when we know that the object is at its highest, its maximum height, because this is where it starts going back down. It's going up and up and up and up and up until it reaches this point, and then it starts going back down on the other side. And so we know that that is where the maximum height of this object's flight path is. And that's how you solve it. If we had, we can also figure out actually what we might be able to figure out what the height of the object is at that time. Yeah, let's try. So we could take the integral of the velocity. So the integral of negative 10t plus 5 is equal to negative 5t squared plus 5t plus c. And so that we could use, we could plug in 0.5 there, and we would see that negative 5 times 1/4 plus 5 times 1/2, that's negative 5/4 plus 5/2, or negative 5/4 plus 10/4 equals 5/4. So that's 5/4 plus c.